The plant smelled of oil and heat, of iron dust and hot breath. Men and women moved between the long rows of jigs and presses as if through the belly of some great animal. Overhead cranes traced slow, patient arcs, while sparks fell like brief, obedient stars. In the offices above the shop floor, engineering drawings lay annotated with cramped handwriting and grease smudges. Range tables, center of gravity sketches, torque values that would decide whether a machine flew or did not. The problem was simple in the way that makes 1,000 small, hard things urgent. Make fighters that could climb, fight, and return long enough to keep bombers alive. Make them quickly, make them safely, make them work. Stay with this account to the end and subscribe for more stories from the engines and factories that shaped history. The forge at Farmingdale began before dawn. Brackett liked that hour. The machines had not yet claimed the rhythm of the day, and the light that came through the high windows was paper-thin, silver along the oil-stained panes. He stood near a pit where castings were quenched, the air sharp with steam. Frederick Brackett had been a metallurgist before there was a war, before there were rush orders and military inspectors. He moved with the authority of someone who had once coaxed impossible properties from metal by patience and precise heat. Now his hands were steady around a cylinder jug that would become part of a P-47 Thunderbolt's engine, and his mind catalogued failure modes. Porosity in the casting, a micro crack at the flange, uneven grain from a mistimed quench. "Sam," he called. Samuel Ortiz, newly arrived from a machinist school and still affixing grease under his nails, came to the pit with a rag over one shoulder. Ortiz was young in a way that Brackett wanted both to correct him and to protect him. His questions were blunt. Why this alloy? Why that hardness? He asked them with the hunger of someone who imagined metal as something that could be persuaded to better behavior if only you knew the right tone. Brackett explained without indulgence. "We need a casting that will hold a valve seat under heat and shock. Aluminum fights at high temperature. We add silicon to help the fluidity, a touch of nickel for strength. Then we control the cooling. Too fast and the grain fractures. Too slow and you get segregation. On the bench, the chemical looks obedient. On the line, it will lie when it's tired." The first runs were brutal. On the test stand outside the machine shop, the R-2800 that would power a P-47 was clamped to its mount like a living thing. The dyno operator strapped gauges to braided lines, RPM, manifold pressure, oil temperature, cylinder head thermocouples that recorded tiny betrayals of combustion. The engine stuttered through its first warm-up, cough, then the steady rise to 2,700 revolutions per minute. The room inhaled when the needle crossed into the recommended power band. For minutes, the noise was a physical thing, a measured, animal roar that made the steel girders hum. A log entry was written in a clipped hand. Endurance run, 3.5 hours at 2,600 to 2,700 RPM. Oil temp stabilized at 190 degrees Fahrenheit. Noted slight valve seat recession at cylinder 6. Recommend revised seat alloy and increase in cooling baffling. The entry was a translation of a violent argument between heat and metal to words the engineers could read. It was precise, unemotional, and final. Failures arrived like weather. On one night in late spring, a technician opened a cylinder inspection port and found a hairline fracture that split from toe to heel. It was coaxed out like a story. Microscopic inclusions from a contaminated ladle, a variation in pouring temperature by a dozen degrees, a quench that had been delayed while a pump was fixed. For every failure, there were small court sessions on the floor. Men with flashlights, blueprints spread on a bench, the quiet deliberation that passed for prayer in the shop. Brackett would sit with a sample under a loupe and, without melodrama, trace the problem to its physical cause. Then the labor began. New tooling, an altered heat schedule, a revised gasket that would relieve a hot spot. The assembly lines ran with the precision of a countdown. Women riveters, their arms a blur, walked flanged skins into place. Final fit men threaded bolts to torque values that had once been theoretical and now were lifelines. Parts stamped Republic Aviation and Pratt & Whitney met on the floor like promises. The Thunderbolt was not small. Its fuselage took up space as if to assert a necessity. The heavy, barrel-shaped cowling to house a powerful radial. The stubby wings that could absorb the torque of the prop and the buffet of guns. Where some aircraft required finesse, the Thunderbolt required mass and a surplus of power. That power came from the R-2800 Double Wasp. 2 rows of 9 cylinders, air-cooled, capable, if coaxed correctly, of delivering the kind of sustained horsepower that turned missions into survivals. A turning point came in the middle of a week when a sequence of small breakthroughs coalesced. They had been testing cooling baffles. A junior engineer had suggested redirecting the airflow around the cylinder heads rather than simply increase the size of the cowl exits. The change was small enough to be implemented on a prototype in a day, and profound enough to lower cylinder head temperatures by perceptible margins during climb. On the same day, a change set in valve seat alloy, more nickel and a different heat treatment curve, reduced the incidence of seat recession during prolonged high-power runs. The plant celebrated in a practical way. There was a brief clapping near the test cell window, a round of handshakes, a coffee mug lifted. Ortiz wrote the new instructions into the binder, a humble act that meant the whole line would follow. Brackett watched and felt something he seldom allowed himself to name, satisfaction that was neither prideful nor smug. It was landscape, the sense that a difficult hill had been worked and that the road ahead, though long, would hold. Tests were recorded in the auxiliary log, terse and formal. Run 0427, 4.0 hours at cruise equivalent, 2400 RPM. Oil temp 180 to 195 degrees F. No detonation. Satisfactory. Recommend certification to service. The words were bureaucratic. In the hangar, they sounded like verdicts on human endeavor. There were injured men, and each injury formed a small public rite on the floor. Robert Kane's shoulder, caught under a swinging chain during a late-night rigging, put him into a cast for 3 months. The plant had rules, but accidents happened anyway. Machines do not consult morale or urgency. Kane sat on a bench with his arm in a sling and signed a casting for a friend who had become a father while Kane was convalescing. The union representative and the foreman argued over overtime and safety checks. Brackett took visits to the hospital to speak with technicians, not as a comforter, but as the presence of the shop. He would talk about the part of the machine that had failed and the part of the procedure that would change. It was a practical consolation. Repair the flaw, change the rule, return the man to work, with an ache and a warning. Outside the factory, the larger world made demands with a bluntness that factories felt in extra heat and a higher tempo. Military officers arrived with maps and timetables. "We need a Thunderbolt that can escort to the targets," one colonel said, his uniform freshly pressed, the lines in his mouth formed by long flights and longer decisions. "We need range. We need altitude. We need it now." Brackett listened, as he always did, not because he loved the words, but because the machine needed requirements to translate into metallurgy and geometry. Range meant additional tanks and fuel weight calculations. Altitude meant attention to supercharger gearing and cooling at low ambient density. The R2800 supercharger would be tuned to provide boost at higher altitudes, and the aircraft would accept a turbocharger routing through ducts in the fuselage on later models, a complex integration that demanded collaboration between engine builders and airframe assemblers. One test flight remained in everyone's memory. The first full-up sortie with the newly balanced engine and revised cooling baffles. The pilot, Eddie Allen, took the Thunderbolt onto the field as light fell in long orange bars across the tarmac. He was a professional who read an aircraft like a patient would read a pulse. The plane rolled, then lifted with a shove that made the whole fuselage vibrate in a way that was promise and warning. Above, the power plant sang a different song. Smoother at cruise, steady through repeated throttle movements, and crucially, without the high head temperatures that had plagued earlier climbs. On the ground, the test stand reported, "Flight 11. Takeoff roll acceptable. Climb rate consistent with projected 3,500 feet per minute at initial weight. Endurance projected beyond 4 hours with auxiliary tanks. Post-flight inspection, no oil seepage, cylinder head temps within acceptable limits." In the brief silence after the report, someone in the shop made the old half-humorous comment that the Thunderbolt had the heart of a bull and the manners of a scholar, wild if taught well. It was praise edged with affection. Success intensified production. The plant's rhythm became a montage of solved problems and new pressures. Each technical advance, an improved propeller pitch control, a hardened crankshaft bearing, a lighter alloy for the firewall, translated into a run on the dyno and then into an operational report. The human scenes threaded through these montages. Letters from wives folded into pay envelopes. A mechanic surprising his newborn daughter by mailing a photograph. A foreman saying little but catching a tear when a young apprentice was promoted to shift lead. Yet the arc of technical triumph carried an ethical weight that the men on the line met in private ways. Brackett, who had never relished speeches, found his conscience tugged in the evenings. On a bench at home, he would handle a small piston from a practice piece, turning it like a worry bead. The newsreels showed cities burning from above. The factories kept building the means. There were conversations that were not public. "We make tools," Ortiz said once as they repaired a jig late into the night. What they do with them is another question. Brackett did not speak then. He thought of his father, who had been a craftsman and had always said that the making itself was a moral act. In war, the line between craft and consequence thinned. Operational deployment arrived with an immediacy that made theoretical debates moot. Thunderbolts left the factory, crossed the ocean on heavy ships, and later on their own, flown to bases in England and on Pacific islands. Pilots who had trained on simulators now spoke of the plane's weight and its tolerance for punishment.
Reports came back describing how the Thunderbolt could take a hit and still return, its radial engine and robust construction making it a refuge in the sky for many airmen. Jack Simmons, a test pilot who later flew combat sorties, wrote a note that the mechanics framed. If it had a soul, it would be stubborn and loyal. The aircraft saw service in both escort and ground attack roles. In Europe, Thunderbolts shielded bombers on deep penetration raids, and on the continent, they hammered at supply lines and troop formations with the same fervor that had driven their design. The plane's heavy armament, its 8.50 caliber machine guns, and the ability to carry bombs made it versatile and deadly.
Reports from the front were technical and heartbreaking in the same breath. Sortie 234, escort successful, enemy fighters engaged at 23,000 feet. Bomber formations sustained reduced losses where fighter cover maintained. Ground attack ops disrupted rail supply at coordinates X. Collateral damage assessed. Civilian areas impacted in vicinity of target. Casualty estimates uncertain. The language leaned toward efficiency, but the facts behind it were human. The ethical pivot was not a single thunderclap, but a braided sequence of images and reports. Factories that had once been sites of sober pride now watched film of devastation and folded envelopes with names for the dead and injured. The language leaned toward efficiency, but the facts behind it were human. The ethical pivot was not a single thunderclap, but a braided sequence of images and reports. Factories that had once been sites of sober pride now watched film of devastation and folded envelopes with names for the dead and injured. The raids left cities devastated and countless lives upended. The men who bolted the fuselages and set the torque values counted the cost in small, private reckonings. Brackett went to a local church once on a gray Sunday and sat in the back among men with grease on their cuffs. He did not pray in a voice that expected answers. He thought about the difference between a thing made and a thing used. Operational logs provided a clinical ledger, increased survivability for bomber crews, measurable reductions in some theaters of losses, the rapid dispersal of enemy air power when confronted by coordinated fighter actions. Yet each success was shadowed by the newsreels of firebombed cities and the whispered accounts that filtered back from occupied territories. Engineers found themselves drafting memos and noticing, almost as an aside, the odd rhetorical slippage. The human costs were counted in metric tons of ordnance and in round numbers that lost the face of survivors. Responsibility, the men realized, could not be absolved by the virtue of good workmanship. It required acknowledgement. In workshops of the Pacific, where P-47s, fitted with long-range tanks, supported island-hopping campaigns, the narrative was similar. The plane's ruggedness suited it to the brutal logistics of the theater. Mechanics worked in heat where bolts expanded and instruments sweated. Pilots wrote home about airfields with coral runways and mosquito swarms. They wrote also of the relief of finding an aircraft that could take flak and still bring them back. Reports logged mission durations, ordnance weights, fuel burn. Sortie 92, 3.7 hours with external tanks. Ordnance delivered. Return 15% fuel reserve. Structural inspection, minor skin corrugation on left wing. Recommend patch and reinforcement. Amid these operational records, human vignettes punctuated the narrative.
a mechanic teaching an island boy to read a gauge, a pilot giving his pocket watch to a ground crew chief, a nurse in a field hospital who wrote letters for men too ill to write. These moments were not sentimental add-ons. They were the sinew that held the technical and strategic bones together, reminding those who worked with metal and calculations that their efforts were threaded into lives.
O clímax da Plant story was not a single flight, but a confluence of successes that allowed the Thunderbolt to serve at scale. A decisive week saw production meet and then exceed forecasts. Engines ran for long hours without a repeat of the earlier valve seat failures. Field reports confirmed improved range and reduced maintenance turnaround. The test cell had recorded endurance runs that would have been unthinkable months before. Sustained cruise equivalents at 2400–2600 RPM for 4 hours. Oil temperatures held under 200 degrees Fahrenheit through improved scavenging, and no detectable detonation across the cylinder bank. The log tersely noted, "Service capable for extended operations. Recommend immediate ramp-up for deployment." Celebration on the floor was tempered by fatigue and the knowledge of what the machines would do. Workers cheered and tapped wrenches, then returned to the torques and tolerances that would take them to the next shift. The plant had become, in a sense, a cathedral of industry. Massive, noisy, devoted to the liturgy of precision. After the cessation of major hostilities, the factory's tempo changed again. Machines slowed, orders dwindled, and men who had known nothing else began to imagine a different life beyond wartime production. The denouement was practical. Retooling for peacetime goods, discussions about workforce training, the salvage of valuable jigs and fixtures. Yet the human retrospection was quieter and sharper. Brackett walked the shop after hours and found a cracked piston on a high shelf. A small object that had been kept because someone, perhaps by accident, perhaps deliberately, had placed it there like an offering. He held it in the light and saw in the hairline fracture not only the failure it represented, but a memory of mornings and decisions and the lives that had been touched by the machine's purpose. In the years that followed, lessons from the Thunderbolt's production informed peacetime manufacturing. Heat treatment techniques refined under duress moved into commercial metallurgy. Assembly line efficiencies found applications in civilian goods. Machining tolerances, once kept for combat aircraft, became the baseline for durable consumer machines. Some men stayed in factories that pivoted to new products. Others returned to school, becoming teachers who passed on knowledge that had once been gained in war. Museums later took the Thunderbolt into glassed halls where visitors could stand before the airframe and feel something like awe. A placard would note manufacturing dates, the engines used, and a short technical description. Near those descriptions, someone would have placed, often carefully, a cracked piston or a logbook page. These artifacts were not relics of triumph alone. They were reminders that machines carry moral weight and that the labor of many hands had real-world consequences. Brackett grew older and quieter. In his later years, he attended a reunion where ex-mechanics and pilots sat in a circle and told the same stories in slightly different ways. Who fixed what at dawn? Who had a lucky break on a run? Who lost a brother overseas? The recollections were not triumphalist.
They acknowledged cost and consequence and held in a kind of civic memory a sober gratitude for the craft and for the lives that had been tethered to it. When the factory finally closed its primary wings to aircraft production, the echo of the Thunderbolt's engines was not entirely gone. Motors and presses hummed in new patterns. The old test cells became exhibition halls or workshops for peacetime industry. In a quiet display case in the local historical society, a small plaque read that the plant had helped deliver thousands of aircraft and had been a center of innovation that touched post-war manufacturing. A cracked piston sat beside it, a small, dark object that had once been inside a heart of steel. The story of the P-47 Thunderbolt's making was not a single narrative of victory. It was a braided account of technical rigor, human sacrifice, institutional urgency, and moral complication. The machines were remarkable. The people were remarkable in their persistence and care. And while the aircraft had helped shape outcomes on battlefields, those who had built them kept, beneath their practical talk, a private sense that the art of making must always come with a measure of reflection about how the tools are used. The legacy was both material and ethical. Manufacturing methods migrated to peacetime goods, and a culture of disciplined problem-solving endured in shops and schools. The Thunderbolt itself lived on in museums and in the stories men told their grandchildren. Occasionally, a visitor would stand before an aircraft and linger not only at the polished cowling, but at the small artifacts, a piston, a logbook, left like a footnote to a larger history. In that lingering, the dual nature of technological achievement could be felt: awe for what human ingenuity could accomplish, and a sober acknowledgment of the price that often accompanied such accomplishment. If there is a final image, it is modest. A museum shelf held a single cracked piston on a felt pad, the metal darkened with age. Near it, a small placard read the technical note, a bore measurement, a recorded test hour, the alloy composition, followed by a simple line that asked the visitor to remember both the craft and the consequences. The piston, once part of a roaring heart, now sat in silence, a quiet object that kept both the memory of heat and the shape of care. If this account moved you, consider subscribing and sharing these stories of engines, of workshops, of the people whose hands turned metal into machines. There are more histories like this waiting to be told. Ellie stood with her forehead nearly against the glass.
The piston looked smaller than she had imagined, its ring of fracture like a dark crescent, the metallic face dull where hands had once polished it until it seemed to glow. Behind the glass, the placard's type was clean and factual. Bore measurements, alloy, test hours. Someone had tucked a single folded sheet beside the piston, a piece of ragged logbook. The top line was in a slanted, confident hand. Brackett read it, and his mouth twitched as if to laugh, and then he did not. He recognized the handwriting without needing to look for the name at the top. It was one of those small signatures a man makes when he knows a thing must be claimed. Initials, a date, a shorthand remark. Replaced, 11:43, temp test 2. The paper smelled faintly of old engine oil and something else. Paper warmed by long storage. The smell of a place where things were kept because people thought they might still be needed. "You knew of that?" Ellie asked.
She was 20, practical in her denim jacket, a student of engineering who liked tolerances and diagrams. She read the line aloud. Bracket, temp high after run, piston show hairline. Her voice had curiosity in it, not reverence, not sorrow. That made him glad. He reached behind the display case and, by some small permission the curator had granted for family artifacts, pointed to a smudge of grease where his finger had once rested. "That's where I cleaned it before we sent it away," he said. His voice kept its Midwestern flattening, a plainness that had outlived any attempt at drama. "We thought the piston would hold another hour. Sometimes we were wrong. Sometimes the roads we fixed led to a place we wished we hadn't gone. You get used to that. Not used like you stop feeling, just used to living with two thoughts at once." Ellie looked at him, then at the piston. "What did you think when you signed that?" she asked. He thought of the night they had found the hairline. A heat chamber had flashed, and the test cell had stank of ozone. He had lay elbows on the bench and sighed, thinking of a son and a postcard and a town that expected results. He had thought of the pilot who would count on that piston's integrity as simply as he had counted on air to breathe. He had thought of the ledger at home with columns that never balanced happily. The machine's needs and the human ledger, both had to be managed. He had signed the log because the truth fit on that line. "I thought the right thing," he said, "or I thought what I could do, and then I wrote it down." He let that be enough. The museum was quieter in the late afternoon. Rays of sun made the Thunderbolt's polished cowl glint in the display bay. Visitors moved through in measured, respectful groups. Schoolchildren with chaperones, elderly veterans with medals pinned to jackets, tourists reading plaques and taking photographs.
The conservationist had placed gloves near a replica crank to remind hands that while the past could be touched, the original objects were fragile and finite. A group of schoolchildren clustered at a display further down, where a strip of fuselage had been removed to reveal the internal ribs. The teacher spoke in the small, patient tone educators use when a metal skeleton becomes a lesson. "You see how the frames support the skin?" she said. "If one frame fails, the load moves to the others. The man who builds the frames knows he is making something that must redistribute trust." One small boy put his gloved hand on the plexiglass as if to feel through it. Brackett watched him and thought of younger men in the plant, hands scarred and steady, faces set toward a job that asked both precision and a capacity for endurance. The line of those men had become a kind of thread through the town. Teachers, machinists, tradespeople, passed down like a technique and a caution together. After the museum visit, they walked across a plaza toward the old plant gates. The brick of the factory had been cleaned and repointed. Windows had been replaced with energy-efficient glass. But the shadow of the main sign remained. The name of the original firm etched faintly and then painted over. New signs announced a makerspace and an apprenticeship program. There were benches and a raised garden where former test beds had once been. The transformation had a pragmatic generosity to it. Tools that had once made weapons were now used to teach welds and molds for prosthetic limbs, to produce parts for medical equipment and agricultural machinery. The noise of presses and lathes persisted, brought under a new ethic. Near the entrance, a bronze plaque had been set in the paving stones. It did not offer triumph. It offered a list. Names of those who had worked there, dates of operation, a single line about the plant's role in the war.
A second panel discussed the plant's post-war conversion, the apprenticeship program, and an admission that the history was complicated. A small inscription at the bottom invited visitors to reflect on craft, consequence, and the choices that give shape to both. A notice board skated with paper notices for a community meeting. The Thunderbolt Restoration Committee had posted an announcement, a proposal to take a Thunderbolt from static display and, after careful restoration, fly it at the town's Centennial Air Show. A hearing would be held. Input was invited. Ellie read the notice and exhaled. "They're going to fly her?" she said. "You think that's appropriate?" He folded his hands and considered the line between remembrance and spectacle. Flying a warbird demanded fuel and pilots and a certain romantic language. Wing arc, thunder, sky as honor. For veterans, the sight of that aircraft in the air could be a resurrection of comradeship.
For protesters and pacifists, the same flight might seem like an unexamined celebration of the machines that had delivered death. He had stood beside men who had sharpened tools for war and then used those same tools to build homes and tractors and playgrounds. He knew wonder and sorrow could live in the same throat. "It will be a story," he said. "How it's told will matter. If they fly it to honor the men who fixed it and to teach what it cost, maybe it's right. If they fly it so people can clap at the noise, then we are learning the wrong lesson." The community meeting was, as such gatherings tend to be, a small theater of earnest argument. The town hall smelled of coffee and floor wax. A line of chairs filled with people who had allegiance to memory in different tongues. Veterans in caps, mothers with strollers, students with notebooks, a few skeptics who had once marched for peace. The curator, Marion, presented slides showing the restoration plan, structural reinforcement, preserved original sections, modern safety wiring where necessary to avoid dangerous failure in flight. The restoration would be done by a team that included retired mechanics who had worked in the plant, and a younger generation of restorers who had studied composites and fatigue analysis. A veteran pilot named Tom spoke, his voice steady but not triumphal. He had flown a Thunderbolt in his youth and had, like many in the crowd, lost friends. "Flying is how I remember the men I flew with," he said. "Up there, you know why you did what you did. But we will not romanticize war. We'll say their names. We'll tell their stories. We will not pretend the sky erases cost." A woman named Sada rose and spoke with slow, considered intensity. She held a pamphlet, a photograph of a ruined village, a child's shoe, images meant to remind the town of the human tally that war accrues far from the polished hangar floors. "Museums are for learning," she said. "If this plane flies, will people leave feeling they saw history honestly? Or will they leave having applauded an engine that carried bombs? The people who suffered on the ground, will they be remembered?" Voices rose and fell. Some argued that a flying Thunderbolt would be a teaching device, to inspire scholarship, to fund preservation, to draw crowds whose fees would support educational outreach about the machine's role in both war and peace. Others feared that the spectacle would drown out nuance. The committee promised an interpretive program. Before any demonstration flight, there would be a talk, exhibits, and testimony from veterans and civilians who had been affected. There would be names read aloud. There would be a moment of silence.
The decision was not unanimous, but the town voted to approve the restoration on the condition that the program be enacted in full. Work began in a former test cell, now repurposed for restoration. The team was an odd, hopeful mingling of ages.
The team was an odd, hopeful mingling of ages. The retired men, apothecaries of torque and memory, brought a tactile knowledge. How a rivet should sing, how aluminum could fail if annealed too long. The small, bitter sweetness of metal that carried history in its grain. Standing beside them, apprentices with laptop diagnostics and micrograph images learned to read corroded alloys as if they were maps of past stress. They argued, they laughed, they traded epigrams about tolerances. A young woman named Priya, who had studied materials, marveled at how the old men could predict failure by thumb pressure on a surface. They, in turn, wondered out loud at the precision of her scanning equipment. Brackett came in some mornings, his back steadier than his knees, and sat by the bench where men shaped pistons. He learned new instruments and taught old ones again. He called a young apprentice over and showed him a technique for peening a rivet so it would not loosen under repeated stress. When Priya asked why he still came, he said simply, "There is a line I know how to finish. It's not just about making it fly. It's about making it right." The discussions continued about what right meant. For some restorers, right meant returning the airframe to as original condition as possible, while incorporating invisible modern safety modifications. For others, right meant augmenting the aircraft with contemporary instrumentation to prevent a catastrophe that would make memory into tragedy all over again. The team compromised. Structural integrity and modern safety for the pilot, with a visible nod to original materials and techniques where the public could see and learn from the contrasts. Rebuilding the Thunderbolt's engine was a slow, almost holy work. The mechanics disassembled pistons and cylinders, measured wear, decisioning which parts, if original, should be conserved. Some fragments found their way into the museum, others into the aircraft, and a few were melted down and fashioned into plaques and small objects for the town. Each choice prompted conversation about the ontology of artifacts. When does replacing a part change the identity of an object? Was the restored Thunderbolt the same plane that had once screamed over fields, or was it now a composite of continuity and careful intervention? A post-war philosophy professor gave a lecture at the plant about these questions. The audience leaned in. The day they rolled her out, the Thunderbolt looked improbable. There was a hush as old men and young women walked her circumference. The paint gleamed under restoration lights. The cowlings sat snug, rivets peened tight. She seemed less like a machine now, and more like a born thing, reborn under human hands. Brackett stood with his granddaughter in the crowd near the flight line. Around them, veterans shared cigarettes or silent thumbs up. There was a man who had once been a gunner, a woman who had patched flak holes in uniforms, children who had traced the aircraft with their eyes. The first engine start hummed and then spoke, an animal unbottled, deep, slow, and then a rising tremor at the back of the chest. The Thunderbolt did not leap. She rumbled and then lined herself as if remembering. Pilots and restorers had gone through checklists countless times, and still hands did not stop shaking. The plane taxied. The prop created a soft fan of air, and then the formation of a single takeoff roll, measured revs, a shriek of speed, and then the machine left the earth. Up there, she was a small dot that made a contrail like a punctuation mark in the bright blue. The crowd watched with a curious mixture of relief and grief, ribs loosening and tightening at once. Some clapped when she landed, some only watched. When she returned, the pilot's face was pale and full of concentration. They held a brief ceremony, reading names of those who had worked on the plane in wartime, and names of civilians who had been hurt by conflict. There was a minute where the crowd offered silence as a shared language. Ellie felt a rasp of emotion she had not accounted for. Pride, yes, an honest admiration for workmanship, but also a strange sadness at how quickly the sense of achievement could shade toward something else. She thought of the piston in the case and the fragmentary ledger note. Her grandfather's signature had survived the years, and now the restored plane carried his handiwork aloft again, transformed by time and care. She found herself weaving the two images together, metal in a museum case, metal under a sky, and recognizing an odd continuity. That craft has a persistence beyond the intentions it first served. In the restoration shop afterwards, the team took pains to host educational workshops. School children were invited to see the inside of an engine case, to learn what fatigue meant, to hold a rivet and understand that craft carries risk and responsibility. Priya created modules on material science. The retired mechanics told stories about mistakes they had made and how those errors had taught them to be better. That candor became a model in the town. People began to speak more honestly about the plant's history, about the good and the terrible intermingled, and to ask what a community does with such a heritage. A tender thing followed. A grant from a veterans group and a peace foundation jointly funded a traveling exhibit that would tour schools and community centers. It carried the Thunderbolt story as an instrument of both bravery and cost. The exhibit included oral histories, recorded testimonies, interactive displays showing where material science learned under pressure helped build safer prosthetics, and a section where children could list what they believed machines should be used for. The list grew as it toured: farming, medical care, art, rescue. The town recognized that the skills and processes that once made bombs could, in hands guided by different values, make life. Brackett lived long enough to see the exhibit leave town for the first leg of its tour. On the morning of his 80th birthday, dozens of former colleagues and their children gathered at the plant's plaza. They brought photographs, a ragged banner, and a cake iced with the outline of a thunderbolt. He received a small book of letters, handwritten notes from mechanics, pilots, students, thanking him for teaching and for the small stubbornness with which he had held fast to honesty in manufacture. He read the letters in a chair under the plane's shadow, fingers slow over the paper. People wrote of his teaching a rivet's temper, of the way he had refused to sign a log until the test read clean. One letter told a story of a man alive today because a part had been made by Brackett's crew and not skimped upon. Another thanked him for sparing the apprentice from a harsh fault by insisting on reworking a casting at midnight when others had wanted to send it out. "You saved them?" Ellie asked him later, the question both literal and seeking some deeper accounting. "I didn't save them by myself," he said, "but I helped make a thing that didn't fall apart when it couldn't fall apart. Sometimes that saves a life. Sometimes it saves a moment, a chance. That's as much as a man can hope to do when his hands are his trade."
There were quieter reckonings, too. At council meetings, the town debated partnerships with manufacturers, the ethics of military contracting, and the obligations of remembering. A local craftsman started an apprenticeship program especially for veterans, offering skills both for work and for therapy. A prosthetics clinic received a donation from a fund raised by airshow proceeds. A scholarship bore the name of a mechanic who had been killed overseas, dedicated to students wanting to use engineering for humanitarian ends. The past, once a single blunt object of memory, had found a way to seed many different futures. Brackett's own terms of memory were simple and pragmatic. He lived in a house that once smelled of coolant and lemon oil, and sometimes of wood smoke from the neighbor's stove. He kept a small chest with his tools, calipers, a hammer with a name whittled into the handle, a steel rule. He would bring a single tool to the reunion each year and tell apprentices why the tool mattered. When his hands grew too stiff for fine adjustments, he taught by showing a younger man how to listen to a motor while the engine idled, learning to hear failure before it happened. Toward the very end, as his conversations wound down into fewer words and longer silences, Ellie read to him from the logbooks. Sometimes he would correct a number or a name, or add one more margin note, like a man who keeps editing the past because it still feels alive. He said little about his fears, and when he did, he spoke of straightforward things: that the young learn to value craft over speed, that the town keep telling honest stories.
The day he died, quietly, in the afternoon, with a radio low at his bedside, the town seemed to hold its breath. People from the restoration team, mechanics from the makerspace, veterans and neighbors came by in a slow procession. They spoke of his stubbornness and of the patience that taught a trade, and they placed a small cracked piston on a cream cloth by his bedside, a private echo of the museum display, where a similar object rested under glass. It was not a dramatic death. It did not seek meaning beyond those present. Yet there was a communal feeling, as if a seam in the town's story had been sewn by a man who simply refused to cut corners. His funeral was not a parade for war. It was a gathering of people who understood that craft could be used for many purposes, and that stewardship mattered in all of them. The eulogies were plain. A friend spoke of how Brackett had once fixed a lathe in a fog of oil and smoke until, by dawn, they had what they needed. A former apprentice talked about nights at the bench where Brackett taught to listen to the metal. A woman from the prosthetics clinic read a letter from a soldier who had regained the use of an arm with a socket whose tolerances had been refined in the plant. They read his entries from the logbooks aloud, small things recorded carefully, so that people would hear a life spent in steady acts of craft. Months later, the museum staff placed a small note beside the pistons display. It explained the restoration project, Brackett's role, and the program the town had built. The apprenticeships, the educational tours, the ethics curriculum developed for students. The note did not attempt to canonize him. It spoke of a life of work, of errors recognized and remedied, and of the idea that people who make things carry responsibility for what those things do. A photo of him was on the wall nearby. A man with hands folded, a small smudge of grease on his knuckle. People continued to come to the museum and touch the barriers and read the placards.
Often, a parent would find a child tracing the crack in the piston and then telling them a story. Something simple about a man who refused to sign a faulty log, or about how machines could be repurposed for healing. The town's makerspace filled with students who had never known a world without that history. They learned to make things and to ask why they were made. Years later, the restored Thunderbolt still flew on special occasions. Each demonstration included an educational program and a moment to name those who had been lost on both sides. People debated the merits of the flight. New groups formed to discuss the ethics of commemoration. But the town had, in one small way, practiced an answer. Not to erase the past's harshness, nor to turn it into mere spectacle, but to keep the craft alive and deliberate, to pass down both technique and caution.
If a visitor now stands in the hangar and lingers long by the case that protects the cracked piston, they might notice a small line added to the placard, a sentence urging visitors to consider what it means to make things well and to ask what those things are for. The line is a gentle instruction, neither prescriptive nor dismissive. It reads simply that skill is a kind of stewardship, and that every object carries the imprint of a choice. Ellie became an engineer who worked on designs for clean water systems in developing regions, drawing from lessons learned in the plant and at the museum. Priya carried on the restoration work and taught materials science at the local college. The apprentices became teachers and innovators, turning lathes that once shaped guns into tools that produce filtration housings and parts for medical equipment. The Thunderbolt remained a complicated symbol. It was an object of admiration for some and of sober reminder for others. But within the town, its presence taught a recurring lesson: that human ingenuity can do harm and good, sometimes within the same span of years, and that what matters is the conversation we keep having about how to use it. On a winter afternoon, years after Brackett's death, a young child in the museum, no more than 8, pressed his gloved hand to the plexiglass and craned his neck to look at the small fracture where the piston had cracked. He did not understand metallurgy, nor did he know the names of the men who had signed the logbooks. He only knew, suddenly, that something made with care deserves thought about how it is used. An older visitor beside him, perhaps a grandson of a mechanic or a pilot, read the placard aloud in a soft voice. The child listened, and with a child's blunt wisdom, he asked, "Are those people still alive who made it?" "No," the man said, "but the way they did their work is still alive. That's why we remember." The child nodded, accepting an answer that was both simple and, in its own way, exact. He walked away and began to draw the outline of the Thunderbolt on the back of a pamphlet, with little notes about what it could do if used for rescue or for teaching. The act felt like a small redemption, a boy taking the image of a machine and imagining futures beyond battlefields. The last image in the museum is not of engines screaming or of triumphalist banners. It is more modest. In a well-lit room, on a felt pad under glass, the cracked piston rests. Beside it, the placard lists measurements, alloys, and hours, and concludes with the same simple line the town had chosen years ago: "Remember the craft. Remember the consequences." Near the case, a child has left a pencil sketch, a crude outline with a small note: "Make things that help." In that small instruction, there is the tether between past and future,
between the men who once signed logbooks in the heat of test cells and the hands that now learn to use the same skills for different ends.
It is not a answer that frees anyone from regret or responsibility. Maze, it is a beginning, an insistence that care, skill, and conscience travel together in the making. Out beyond the museum, on certain clear days, a restored thunderbolt arcs across the sky. People look up, some with tears, some with fists in pockets, some with notebooks in hand. They each carry different memories shaped by their own lives. The sound of the engine is both a technical marvel and a reminder. It is a voice that calls to both the past and the present. And under that sound, in hangars and classrooms and kitchens, a quieter, persistent work continues. The work of teaching hands and hearts how to build what sustains life.